Today we're going to talk about fuzzing, more specifically about how to make fuzzers in Rust using the Honggfuzz and the Libfuzz library. First, let's talk about why we choose Rust, since fuzzers are tools that can be implemented in many other ways. In this case, we use Rust because it is a language focused on performance and security, which help us in the task of making or testing a secure code. The main characteristic that Rust offers us for this purpose is to provide memory safety without a garbage collector. Additionally, Rust's static type system is safe and expressive, and provides strong warranties for isolation, concurrency, and memory safety. Rust also offers easy integration with other languages. To make fuzzers in Rust, we can use Honggfuzz and Cargofuzz libraries. Honggfuzz is a project for coverage-guided and mutation-based fuzzing, currently maintained by Google. It is security-oriented, feedback-driven, and easy-to-use fuzzer with interesting analysis options. A disadvantage of this library is that it is not compatible with Mac systems, so to be used, a VM or a Docker container must be used. On the other hand, Cargofuzz is a subcommand for fuzzing with Libfuzz, which is a library for coverage-guided and mutation-based fuzzing. Although its original authors no longer support it, there are still people who maintain it, fix bugs, and provide other updates, but no new features will be added to it. It is very easy to install, has no compatibility issues with Mac, and also can be used with or without seed inputs. Let's see an example of how to use Honggfuzz. As we see, the source folder contains the main file where the fuzzer is. In the hfuzz workspace folder, we find the elements used by the fuzzer, that is, inputs used, the crash report, and the files that trigger the crash. Let's examine the code structure. Firstly, we have the library declaration, followed by a loop that executes the fuzzer. Inside the loop, there is a fuzz function that generates an input called data. The fuzz implementation is contained within the fuzz function, and it uses the data to conduct tests. To use this tool, we first need to install Honggfuzz. You can do it with the command cargo install Honggfuzz. Then, to create the fuzzer project, we use the command cargo new and the repository name. And once you made the fuzzer code, use cargo hfuzz run and the project name to run it. There are a lot of additional settings you can use along with the fuzzer. You can start with certain inputs or use a dictionary to generate inputs of a certain type, and a lot of other functionalities that you can see checking the documentation. And the execution would look like this. The execution does not stop until it encounters a crash, but until you manually stop the fuzzer. Now this is an example of a fuzzer in Cargofuzz. For this fuzzer, the structure is the following. In the fuzz folder, we have the targets, that is, the different fuzzers that we are going to do. Then, the corpus folder contains a collection of generated inputs, and we also can have an initial collection of inputs to give us a seed to the fuzzer. In the artifacts folder, we have the relevant information of the crashes and the file that triggered them. As for the code structure, we first declare the libfuzzers library, which allows us to use the fuzz target function. Within this function, we use the data variable, which is generated by the fuzzer to test our code. To use libfuzzer, first we install Cargofuzz with the command cargo install cargo-fuzz. Then initialize the necessary folders with the command cargo plus libfuzz init. To add a new target, run cargo plus libfuzz add and the name of the new target. After that, write the fuzzer and use the command cargo plus libfuzz run and the target's file name to run it. You can run the fuzzer with other functionalities, which can be checked using the command cargo plus libfuzz-help. And the execution will look like this. It takes some time to start. And then, once it finds a crash, it stops. Also, along with the fuzzer, you can use tools like sanitizers for a more complex analysis. Both tools allow corpus minimization and running the fuzzer with certain inputs. This was an introduction to Honggfuzz and Libfuzz libraries. If you want to try them, always check the documentation and complementing tools available for these libraries. Thanks for watching and see you next time. Bye!